Well, hello.
Solutions.
Oh.
Have a sip of your solution.
My favorite solution.
Delicious, delicious solution.
Not only this is a solution, this is my answer.
There you go.
Just saying.
Welcome to Regents Chemistry Solutions Unit.
Unit 6.
Yeah, I've lost count.
Yeah, we flying.
Yeah.
Ooh.
This at the end of this unit is the halfway point
Yeah,
of the course. Really is.
Yeah, and you thought Christmas break was the halfway point.
Wrong.
Well, wait till my kids will actually be doing this over Christmas break, so
I hope my students do work over break.
mine will. I have some that will, and I have some that will.
So our EQs this unit are basic overarching questions. Why do some things dissolve in water while others don't?
Yeah, and we'll figure out what dissolve even means technically
Yeah.
if you don't know that. And why do ionic compounds allow water to conduct electricity? You mean the light bulb's going to light?
Remember that chemical bonding lab where it lit up? There it is. Why? Why does like dissolve like work as a rule for solubility? It's this thing that we say, but what does it mean?
Yeah, we're so alike, but we're different. We're alike. How does temperature and solvent volume change solubility? What are the factors?
Facts. How do you quantify solubility beyond saying it's just diluted or it's concentrated? That coffee is really concentrated. I like my coffee a little more dilute. But how do I put a number on Mr. Milks' coffee?
We can measure. And then, of course, you'll have to figure out what on earth dilute and concentrated means before we put a number on it. What happens to the properties of water when solutes are added? Can we bump up the freezing point or lower the melting point?
Yeah, we can change these things.
Yeah, I got it mixed up. But that's all right. We'll get it straight in class.
So targets, ICANS, identify a solute and a solvent when a solution is created. Which one's a solute, which one's a solvent? You will have to know.
Yep, that's a big one. You'll be able to use table F to predict the solubility. Will it dissolve or will it not?
Can you tell if a solute is going to dissolve or dissociate when placed in water? So ionic versus covalent.
Shucks. Light the light bulb or not light the light bulb? Use the term like dissolves like to determine if two substances will mix or will you be able to dissolve something.
Right. It's based on polarity.
Back
to chemical bonding.
Yep.
State relationships for factors that affect solubility of solutes in water. So things like, if the temperature increases or the amount of ingredient or solute increases and changes, what will happen to the solubility? We want to know.
Yep. And what he's talking about there is how much
will
dissolve. That's what he means by solubility. Use table G. This one's fun. Might be 2 videos.
Yep.
We'll see if we can get it all in one. Classified solutions as saturated, unsaturated, or supersaturated. We need to know what each of those terms means, and this chart will help us track temperature and amount of stuff. We'll be able to tell.
Reference table heavy unit.
Yes.
Using table G, again, find changes in amounts when the solvent temperature or volume is changed. So if you change the temperature, what happens to the amount, how much solute dissolves in it, etc.
Right. If you change the amount of solvent, how much?
Yeah.
Then we get to calculate the concentration. We call this molarity. There's also parts per million and percent volume given for solutions, if you will. Table T molarity will be the big
Math.
Molarity will be the big one.
Compare concentrations. So you need to be able to look at two concentrations with their concentration number values that have been given to you and say, well, this one's more concentrated than that one, or that one's more dilute than this one, based on the values of molarity or parts per million or percent volume or percent by mass.
Predict how adding a solute to water will change its physical properties. Hence, its boiling point goes up, its freezing point goes down. That sounds like a lab.
It is.
Good. Oh, speaking of labs.
Tracker 2.0.
3 labs this unit.
Yes.
3. And notice there's barely really a POGL. It's actually a simulation POGL, a bunch of those FETs put together to just kind of get another way to look at it.
Right, because you can't see atoms. So these simulations are good because they show you the atomic level what's going on.
This particular unit lends itself to tons of labs to figure out how this stuff works rather than the POGLs.
Right.
And then so the practice pages are going to be pretty important too. And if you look at a few of them, there's 3 and 4 pages of practice on some of these tasks.
Yes.
So it's going to be practice page heavy and lab heavy. I hope that you are ready to get your learn on.
See you next video. a clicky button, attorney off. Clicky